that the sine of an angle is equal to the opposite over the hypotenuse, that the cosine of an angle is equal to the adjacent over the hypotenuse, and the tangent of an angle is the opposite over the adjacent. Okay. And it totally depends on perspective. Okay? If I stood in this corner of the room, which corner is opposite of me? Shelby? Your corner back there? Okay, that corner back there is opposite of me. These two would be adjacent to me because there are things that connect us that create touching lines, right? Like sides of triangles that would connect these two angles together. That would be opposite of me because I don't touch that corner. But if I change my position, if I look at it from a different position and all of a sudden I stand over here, opposite is no longer the same thing. Where is my opposite now? Over there, right? So it completely depends on perspective. So when you look at this triangle, okay, if I say, what is the sine of theta? So this weird looking little letter right here is theta in case you don't remember from geometry. Okay. So if I say, what is the sine of theta? And you go to your head and you do your SOHCAHTOA thing and you remember that sine is opposite over hypotenuse. From this angle, what is considered the opposite? A. Okay? A is the side opposite of that angle because it does not touch that angle. All right? What side would be considered the hypotenuse of this triangle? C. It should be more properly marked with a little right angle in that corner. You guys can fill that into your notes. But C would be the hypotenuse. So in this case, the sine of the angle in this example would be A over C. Okay? Cosecant is another trig function that is basically the reciprocal of the sine. Okay? So you'll want to know that the cosecant or the CSC is 1 over the sine. Basically just flip over whatever you get for your sine. Use the reciprocal. Okay. So for the cosine of the angle, so cosine is adjacent over hypotenuse. Now there are actually two sides that are adjacent to this angle. What two sides are adjacent to this angle? C and B. But C is special. What name do we give C? Hypotenuse. So unless you're talking specifically about the hypotenuse, you're not going to use C. So adjacent means the other side touching it besides the hypotenuse. So when we go to do the cosine and we want to set up the adjacent over the hypotenuse, the adjacent side would be B in this case because it touches the angle, and then the hypotenuse is C. And then the secant is what we use as reciprocal of the cosine. Tangent is opposite over adjacent, so in this case it would be A over B, and cotangent is the reciprocal of the tangent. Okay? So on your paper, you would want to make sure that you know what the ratios of sine, cosine, and tangent mean, that you know that cosecant is the reciprocal of the sine, secant is the reciprocal of the cosine, and cotangent is the reciprocal of the tangent. If you have a hard time remembering which one goes with which, each pair only has one word that starts with co in it. I know it's super silly, but whatever. People don't usually mess this up, tangent and cotangent, they get it. But people tend to kind of like mix up these ones, okay? But if you're talking cosine and it already has co in front of it, it's not going to go with the cosecant. Only one co prefix in each pair of things that go together, okay? So make sure that you have that information. How many of you guys totally remember this from geometry? You're good. Okay. They are just saying they remember. This is their own perception of their learning. Okay. All right, so get whatever you guys need. How many people still need the slide up? Totally not judging. I just want to make sure I don't change it when you're still writing stuff down if I'm going to make you write stuff down. Well, you can write down as much of it as you want. You want to make sure you know what sine, cosine, tangent is. So if you wrote this, it's fine, but you might want to make a note next to sine that like cosecant is 1 over the sine, and like secant is 1 over the cosine, and cotangent is 1 over the tangent, that those things go together. The note guide is also still online, so after you see what it looks like and you're like, oh, if I had that, I wouldn't have to write down as much stuff, you can totally go home and print it out and transfer it over and just use that each day. It's up to you. Okay. I'll give people a minute that need it. For angle theta. So we want to find what the sine of theta is, the cosine, and the tangent. And then we want to find all their reciprocals. So remember, the reciprocal of the sine is the cosecant. The reciprocal of the cosine is the secant. And the reciprocal of the tangent is the cotangent. All right, so I'm not worried about decimals. We can just write it in fraction form and use what we have up here, okay? All right, who can give me the sine of theta? James. Good. Are you guys good with that? Here's where he's looking from. Opposite over hypotenuse. So because our perspective is all based on this angle, this is the hypotenuse because it's across from the right angle. That makes this the opposite and this the adjacent. Now, if they switched the angle up and all of a sudden they wanted me to find something from angle B, 13 would still be the hypotenuse, but I would have to change my perception of what is adjacent and what is opposite each time they change the angle that I'm talking about. Okay? So opposite over hypotenuse, so 5 over 13. All right, somebody else, the cosine. Shelby? Good, 12 over 13. Notice she's picking out the adjacent over the hypotenuse. All right, what about tangent? Yeah? Say it again, sorry. 5 over 12, so our opposite over our adjacent. All right, who can give me the cosecant? James already gave us one. New people. I know it kills you guys. It'll make the class go by faster if you do stuff. I promise. Out. Good. Okay. If you know that the cosecant, so I'm going to be perfectly honest with you guys. I don't measure or memorize, if I could speak. I can barely speak, so clearly I don't memorize very much. I don't memorize how to find the cosecant. I memorize how to find the sine, and anytime someone asks me a question about the cosecant, I go find the sine, and then I flip it over in order to find the cosecant, okay? Because I don't have any extra space in my head to remember extra stuff that people need me to remember, okay? All right, secant. New person. Okay?
13 over 12.
Good, because I remember that it's related to the cosine. And then finally, cotangent. Linnea? Good. All right, so this is kind of like the most basic thing we'll do with this is we'll just pick out what the ratios are based on the sides. Why would we do this? Eventually, you could then use a calculator and some inverse functions, and you could actually go determine what that angle must be if the ratio of the tangent is 5 over 12. There's a way for us to go solve that equation and figure out what it is. That's going to be our focus tomorrow, okay? Our focus today is going to be either just writing these, or if we have missing sides, how to figure out missing sides. Okay? All right, if you have the note-taking guide, if any of you guys did print it out, did anybody print it out, or am I just wasting? Okay, if you have the note-taking guide, because we're not doing the inverse functions till tomorrow, we skipped around a little bit. So if you go to the section that has try this problems, then we want to look specifically at these problems. So your job right now is to find the cosine of S. So this is all in the note-taking guide, just not like in sequential order, because we're saving some of the problems for tomorrow. The tangent of angle T and the cosecant of angle S. So, okay, so how did he get that? So first of all, he's looking for a cosine from angle S. So first of all, your perspective has to come from angle S. Okay. What does the cosine use? Which sides of the triangle? Adjacent and hypotenuse. Okay. So if I put the adjacent over the hypotenuse, I would technically get 3 over 3 rad 5. Okay. What did he do from there? Why does his answer look like rad 5 over 5, and we write it and it looks like 3 over 3 rad 5? Alex? Good. You can cancel out these 3's too, even if you want before you do that, but we need to multiply by rad 5 in the numerator and denominator to not leave a radical in the denominator. Now, you might hate this and feel like it's a lot of extra work, but you guys saw some of those college entrance problems. Do they expect you to know how to do basic things with radicals? Yeah. So this is not bad practice for those kinds of things. So then we get rad 5, because 1 times rad 5, and then here rad 5 times rad 5 will give us 5. Okay? So the rad 5 over 5 is the simplified version. So here's what you need to ask yourself. Did you pick out 3 over 3 rad 5? If you did that, you're picking out the right ratio. Okay? So the trig part of it, you understand which sides of the triangle to use. If you didn't know how it became rad 5 over 5, you just need to work on some of your radical simplifying ideas and pay attention to those. Okay? All right, tangent of t. Who thinks they could give us information about that? What's that? 2? Okay, so what angle are we looking from now? T, right? So our perception is here. Are the opposite and adjacent going to be the same labels that they were when I was using angle S? No. Okay. What's opposite from angle T? 3. So this is now the opposite if I'm looking at angle T, and this is the adjacent. Okay. So how do we put together a tangent ratio? Opposite over adjacent. So in this case, 3 over 6. So that does reduce. It'll reduce to 1/2. So our tangent of angle T should be 1 over 2. Okay. Is that okay? Yeah. So the hypotenuse doesn't change, but each time you change which angle you're working with, you've got to change your adjacent and your opposite idea. Okay. All right, the last one, the cosecant of S. So going back to angle S, first of all, before we do any of this is going to come back to being the adjacent, okay? And this is going to be the opposite when I'm working on this problem because I'm using angle S as my reference. All right, so who can tell me how we can find the cosecant of S? What do you guys want to find first? I personally wouldn't be like, oh, the cosecant, I know how to do that. What would I look for first? The sine of angle S, right? And then I would just take its reciprocal. So what is the sine of angle S? 6 over 3 rad 5. Now, before you go on rationalizing the denominator, think about what you're doing here. Is that our final answer? No. We want to use the cosecant, so we're going to go ahead and take the reciprocal. Kind of rationalized itself when we did that, right? And then these can simplify, so we end up with rad 5 over 2. Is this all right with everybody? So we understand the basics of how to label the triangle, how to pick out the ratios, and which ones the cosecant, secant, and cotangent are related to, so we can find them and then use their reciprocal. Any questions about any of that? No? All right. So those of you that have the note guide, this is example 5. You guys can go there. So the directions in this, so if you don't have the note guide, just label it example 5. I know that's out of order of what you did, but it'll make sense if you end up getting the note guide. And the directions are just to solve the triangle. So do you guys remember in geometry, if someone told you to solve a triangle, what were they asking you to do? Alex? Good. All the sides and angles. Everything that you need that's missing. Okay? So in this problem, the things that are missing, angle-wise, I need to find the measure of angle y. Okay? And then side length-wise, I'm missing side xz, okay, from x to z, and also side yz. When I have these 3 measurements, then I've completed the problem. Okay? All right. 23 is the one number they give us. Okay, and 23 happens to be across from the 90-degree angle. That means no matter which angle I use, 23 would be considered the hypotenuse. Right? So I can label that part of the triangle. It's not going to change. The other parts, which one's opposite and which one's adjacent, is going to depend on which angle that I choose to look at. Okay. So first, can you find the missing angle right now without doing any trig? Okay, we can, by knowing what piece of information? Okay, so a right triangle has 90 degrees here, and how many degrees total in the triangle? 180, okay? So if there's 180 degrees in the triangle, and so far I have 90 plus 63, that's 153. If I subtract that from 180, then I have 17 degrees left. Is that right? 27, because I can't subtract. Good thing I can do lots of other stuff, right? Okay, so 27. So this will be 27 degrees, and I've already found a third of my answer. Okay. Now I have to find the sides. What are other options besides trig that you can find the sides of a right triangle? Famous theorem. Pythagorean theorem, right? In a right triangle, the whole a squared plus b squared equals c squared thing, okay? Right now, could I use that to find the missing sides? No, it would suck, right? Like a squared, there's nothing there if I call this a. Let's say I call this b. A squared plus b squared equals 23 squared. Okay, I have two variables. That's not going to help me. That's your red flag that you would have to use trig. Okay, clearly we're studying trig, so it's not going to be that hard for you guys to figure out. But if you were taking like a college entrance test and looking at a triangle, you don't want to always use trig. If they gave me a number here, I'd probably much rather just use Pythagorean theorem. It'd probably be easier, right? Okay. But I'm going to have to use trig because I don't have two of the sides. So I need to set up an equation that finds one of these for me. Okay? Not both, but just one of them. I know I have to use trig because I don't have enough for Pythagorean theorem. So if I'm going to set up a trig equation, whether I use sine, cosine, tangent, all of the equations did sine, cosine, some trig thing to an angle, and on the other side they were equal to two sides. Okay? So I need to know which angle I want to use as my angle. Doesn't really matter. You can't use the 90-degree angle. Okay? But you can use the 63 or the 27. Which one do you guys want to use? The 27? Sure. Okay, so I'm going to use this angle as my perspective. Okay? So I'm either going to take the sine, the cosine, or the tangent, something of 27, and then it's going to equal to some ratio between the two sides. Now be smart about which trig function you pick. There's more than one option, but there are some things you can't use. Like, would it be smart for me right now to write an equation using the tangent of the 27-degree angle? Okay? Tangent would use opposite over adjacent. If both A and B show up in that equation, am I going to be able to solve it? No. Okay? So I don't want to use tangent, but there are other options. So what do you guys want to use? Sine? Okay, so let's say I choose to use sine. Okay. So the sine of 27 is going to be opposite over hypotenuse. So opposite, which is my variable A, the little thing that's missing that I don't know, over hypotenuse, which in this case is 23. How are you going to solve this equation for A? How are you going to get A alone? Yeah, you just have to times by 23, right? I mean, I know it looks a little confusing because you got like words like sine over here, but really to get A alone, all that has to happen is we need to multiply by 23, so those will cancel. And then this side would have to be multiplied by 23 also. So this is the number 23 times some other number, which is whatever number we get from this calculation. Your calculator can do that calculation for you. Okay? So you can do it right now on your phone calculator or on a different calculator. The one thing you'd want to make sure of is which mode your calculator is in. 27 is what kind of measurement, like what units are on the 27 degrees. So you'd want your calculator to be in degree mode so that when you do that calculation, it's actually looking at the 27 degrees. Okay? So if you are using one of these calculators, there's a mode button right next to the blue second button. Just make sure it's in degree. Okay? And then you can do 23 times the sine of 27. And then you should get that A is equal to 10.4. So that's for this. If you were taking some sort of entrance exam or something like that where they didn't allow a calculator use, like we saw with some of like the SOAR practice tests and stuff like that, they would leave answers in this format if you weren't allowed to use a calculator. Or as you saw in the past on some of the tests that you take, like when you guys were taking geometry, you had to probably take the CST. They either leave the answer like this or they give you a little box off to the side that says like the sine of 27 is about equal to this decimal. Cosine of 27 is about equal to this decimal. But they give them all to you, so you can't really like help pick which one is which. You know. All right, so 10.4 we figured out. That's from x to z. And then we still need to figure out the length of yz, or what I've labeled b in my triangle. How would you guys go about figuring that out at this point? Okay, so we could set up the cosine. So we could set up another trig equation. where we use the cosine of 27, because that would equal adjacent over hypotenuse. And then we could solve this the same way. Multiply both sides by 23. So that that length is equal to whatever we get when we do 23 times the cosine of 27, which in your calculator should end up being 20.5. What's another option for how you could have figured it out at this point in the problem, since we had already completed one of the side lengths? Yeah, you could go through and do Pythagorean theorem. So at this point, and you would have a calculator if we were asking for these decimal values. You could do 10.4 squared plus b squared equals 23 squared, and you could solve that equation, and you should get this same answer. There might be small rounding differences, but there shouldn't be very big differences in your answer. The last thing you should do is you should make sure your answer makes sense. Triangles have to work a certain way, and you guys learned a lot about this in geometry. How much you remember, like I said, I don't know, right? Depends on the individual. But if these are my answers, okay, there's certain ways the side lengths have to behave when compared to the angle, right? Like, what do you know about the hypotenuse of a triangle compared to the other side lengths in the triangle? It's the longest side, okay? Does anybody know why we know in relationship to the angles why this one is bigger for sure than these other two sides? Shelby? Good. Okay. So length of sides can't just be found by angle measurements, but how big the angle is tells you how big the side across from it has to be. If I make a teeny tiny angle with my hands, do I need a very big side length to connect my finger ends together? No. But if I decide to make that angle larger, I'm going to need a much larger something to make the third side of that triangle, right? So it kind of makes sense logically. Across from bigger angles, there needs to be bigger sides in order to connect them. So the side across from the 90-degree angle should be the longest side in the triangle. So when you guys finish the triangle, this should all make sense. Was 23 the longest side of our triangle? Yes. Good. Okay. 27 was the smallest angle, so therefore across from the 27-degree angle should be the smallest side. I know it doesn't look this way in the picture, but pictures, unless they say they're marked to scale, aren't marked to scale. Was 10.4 the smallest side of our triangle? Yes. Okay, so I'm bringing this up for two reasons. One, to review for you, because geometry is not a place you guys get a lot of review, but you saw that some of those concepts show up on entrance exam tests and stuff like that. But two, you can also check very quickly if at least your answer somewhat makes sense if you kind of understand how the things are supposed to work at the end. Okay? So these measurements would work. They seem to make sense. Okay? I know that we did the right thing to find them, so we're good. What's that?